away.
Thank you for the reminder, Mayor, that we are going to record this. This is not something that I do every day, so.
That was a
I
subtle
actually just
reminder.
started the recording. So Mayor, I didn't get your, I did not get your introduction.
That's just fine. You're going to get to the important part now.
Yeah, well, thank you, Mayor, for welcoming us. I told everyone yesterday, the mayor's good at welcoming folks to Defiance, even when it's virtually. So I appreciate your help with that. And let's see, here's our agenda. I know you probably all have seen this. It hasn't changed really, other than I've added some times. I'm optimistic that we can have a good discussion down here about where we might go next with phase 2. And still have a good discussion and still wrap up a little bit early. So so this will be, I'll put this back up on the break. I just built in about 10-minute break here between the panel discussions, just to give folks a chance to get up and stretch. And but obviously you can do that at any time. I think just a little housekeeping. I think everybody is probably muted and cameras off. So if you have questions or if you want to add anything or make any comments, just go ahead and use the chat function. I've got some folks that are helping me monitor that. So yeah, any questions or comments along the way, just like I said, use the chat and let me know everything. If anything is needed or anything seems like it's not going well, but we'll just keep moving through this. I just wanted to thank Shelby and she's our sort of liaison, I guess, for our grant project with GLOS, the Great Lakes Observing System. So I will let her talk about that and talk about their mini grant program, but our application we put in, so the City of Defiance, along with a lot of help from Bruce Cleland from Tetra Tech and Rachel Martin, she's an intern here at the city when we applied for this grant. Obviously, our whole team at the City of Defiance has been working hard on this issue. But Rachel and Bruce really helped us get the grant application together. And so that was about a year ago. In the spring of 21, we applied and were awarded about $90,000 in funding. Most of that is going towards equipment. We'll hear more about that, the new lab, Green Eyes equipment that's installed at the water treatment plant. Adam is our superintendent at the water treatment plant, and he's been telling us for years that we need to have a continuous ammonia monitor. So that was really our main focus. Adam will talk more about the issues with ammonia in Maumee River, specifically the upper Maumee River. And Mayor already mentioned the source water protection plan. Joe Ewers did a great job working on that. We worked together and worked with the staff at Ohio EPA to get that plan endorsed probably over a year ago. COVID has everything kind of in a time warp, so I can't tell you exactly the time frame on that, but that was really the focus of our grant application, was to, I guess I would say, take the concepts that we've heard so much about with the Smart Lake Erie and all the great work that's being done around the Smart Lake Erie issues, and really try to apply that concept to the watershed. Take that methodology and take that vision upstream and look at the upper Maumee River. So how can we apply that same concept and really, understand better what the Maumee River is doing, manage the reservoir better, manage the water treatment plant better, and then also really contribute to the overall goals of the research community and of the folks that are monitoring regionally, right? How can this equipment that we're installing be valuable beyond just the city? That was our main goal, was to have those process controls at the plant. So, so given that, the slide doesn't want to advance. A couple of additional folks in the waiting room. There we go. I just wanted to share this, the map of the Maumee River Basin. Obviously we also talk a lot about the Western Lake Erie Basin. So you'll see that that outline here. For those of you that are not familiar with the watershed, this sort of grayed out area, really all contributes to the Western Lake Erie Basin, but then this map specifically shows the Maumee River Basin. And some of you may know, you've come to understand that the Maumee River is actually the largest, has the largest drainage area of any river in the entire Great Lakes system. So Defiance sits centrally located in that. And, you know, our geographic focus area is really very specific to the Upper Maumee, which is where our drinking water comes from. It's really the sole source of our drinking water. And we believe that we're the only community that actually uses the Upper Maumee River for drinking water. So our portion of it here in Defiance County is just a pretty small area. That's where we're very, very focused at this point. So I will let others talk more about that. I think I'll stop there and see if Shelby is ready. Shelby, I don't know if you have slides that you want to share. You should be able to do a screen share.
All right, it says you have to stop sharing and then I should be able to share, hopefully.
Yeah, sure thing. Go. So Shelby, I have a little biography for you that I'd be glad to read.
Great.
Right, folks, I am not, there we go. Okay, so Shelby Brunner, is it Brunner or Bruner?
Runner, yep.
Bruner, okay. Shelby joined the Great Lakes Observing System as their first observing technology manager almost 2 years ago. Previously, Shelby served as a project manager for large-scale oceanographic projects at NOAA's Global Ocean Monitoring and Observing Office. She has research experience in Great Lakes hypoxia and biogeochemistry, sediment dynamics, and water quality evaluation. So I asked Shelby just to give us an overview of GLOS and of Seagull. If that is that's what we're ready to do next, then I will pass it. I will mute myself and then pass it over to Shelby. So thank you.
Thanks so much, Jen, and good morning, everyone. I'm excited to be here and represent GLOS and to hear the discussion about this project that GLOS is really excited to help support. So I have a split screen, so I'm looking over at my left. That's where my cursor is. Trying to keep my face forward though for everyone. So as Jen said, I'll give a really quick overview on what GLOS is, our new Seagull data platform, and then the 2021 mini grant program that supported this project. So GLOS, or the Great Lakes Observing System, is part of the Integrated Ocean Observing System, or IOOS. I promise this is probably the most acronyms I'll use on this first slide right here, get them all out of the way early. IOOS's purpose is to provide high quality oceanographic and Great Lakes information to the public that meets a variety of stakeholder needs. So they do this through a variety of open access data portals, as well as stakeholder engagement and reach out. There are 11 regional associations across the United States that are a part of IOOS, ranging from the Pacific up to Alaska and over to the Caribbean. GLOS is the Great Lakes component of that and the sole freshwater observing system regional association for IOOS. So when people think about GLOS's data access, they probably traditionally think about this GL buoys page. This is what has served the public for many, many years. And there were a number of other platforms that were also associated with it, but this is the one that usually got the most hits in a season, you know, up to 1 million per season. This is a picture from prime 2021 field season. So you can see we have really nice geographic coverage across all 5 of the Great Lakes, as well as even Lake Champlain when they deployed their buoy. So GLOS does not own and operate all of these assets. That would be impossible and it wouldn't be right. So we rely on partners such as Defiance and federal, academic, nonprofit, private, all partners that deploy platforms that want to share their data with the public. They can reach out to us and we will work with them to get the information on our portal so it can be viewable by the public. So a lot of the platforms that you see here are typically moored buoys or SONs, even meteorological towers in some cases if it's on land. So if you, for example, click on a station, if you click up here by Sleeping Bear Dunes, you can see it would take you to this new data page where it would show you the most recent information, including any webcam imagery or buoy location information that we have. So the Great Lakes Observing System, the amount and variety of platforms that we support on our portal is expanding quite quickly. As I said, the primary types are buoys, towers, and SONs, but we're also seeing expansion into new areas, including high frequency radar, which we got the first ever Great Lakes one established at the Mackinac Straits last year, environmental sample processors, which give real-time toxin information about microsystems, and then uncrewed systems, and I'll give some examples of these, as well as models. So there's a number of Great Lakes-wide models that are developed that are important, and that observing and modeling efforts shouldn't be as siloed as they historically have been. So GLOS is trying to think about ways to be able to support these expanding systems and interests of our operators. So very quickly, a couple of pictures to give you an idea of some of the new types of platforms that we're looking at GLOS. In the top right, this is a Slocum glider. Many of these are starting to be operated on a seasonal basis. And this is in the middle, an autonomous surface vehicle. These are both examples of uncrewed systems that we've seen a large push from because they're safer for reduced human risk, and they can go places where a ship might not be able to go. This high frequency radar in the bottom right is one of, it's a tower that's based in the Straits, and it measures surface currents across the water. So it's located just off of the Mackinac Bridge. And this is really interesting because it's one of the, it is the first in the Great Lakes to be established operationally, but they're very common on the coastal, on the coast. So we're excited to be able to see the applications and where the usage for this goes. And then over here on the left is an example of a more traditional type of buoy in the back. This is, a larger surface buoy with a MET station. And then in the forefront is what's called a SOFAR spotter buoy. So these are about the size of a large kickball, and they're more easily deployed by a 1 or 2 person team on a smaller vessel. They're lower cost, and they have really expanded. We probably have, I would say, 15 to 20 that we now serve data for around the Great Lakes. And this just happened in the last 2 years. So those are an interesting new platform that we've seen a lot of growth for. And all of this growth is really contributing to the Smart Great Lakes Initiative. So the Smart Great Lakes Initiative is a common set of goals between US and Canadian groups to help further Great Lakes information. And really the goal is to organize an information ecosystem for improved monitoring, advanced data management, and analysis. And our goal at GLOS is to develop, expand, and really leverage these technologies to improve our collective knowledge about the lakes, and in turn make recreation, commerce, water quality, and our lives better using this technology. And GLOS's specific contribution to this is to build an information platform that supports a variety of smart devices that ultimately drive information and delivers actionable intelligence. And this platform is called Seagull. And Seagull is something that we've been working on for a number of years. And I'm going to give you, this is a screenshot of our Seagull beta page. So you can go here and visit and see what's happening. But this new data portal will replace our old portal. It has integrated model information, including forecast for water currents, surface water temperature, and wind speeds. There's more search functions, and eventually it will support these newer types of platforms that are coming online that we couldn't support in our old platform just because of its legacy and its the way it was built. So I welcome you to go check it out, and I'll give you a little bit of an idea of how far we've come with this. So this is the timeline for the Seagull development. It started in 2019, if not before, with an initial prototype that we called Chick. And we did an RFI and RFP to find professional groups that would help us build this platform that we knew was critical for Great Lakes data sharing. And now we're here. So we're at the very end. We actually publicly launched seagull.gloss.org next Thursday at Glossapalooza in Chicago. So as of next Thursday, you'll visit the Seagull live site and you'll get to see it continue to grow. A lot of the capabilities that we want are there, but there's still a lot more that we want to add and that we know that we can add. So we're really excited to be able to launch this and see how it takes off. And I should note one other thing about Seagull is that it's meant to be a platform and not an application. So if you or someone that you know has an interest in like building an application to go on top of it, it's meant to be a way to leverage other developmental things and not just be a platform. And so while this was being built, the Smart Great Lakes Initiative was also growing. And Smart Great Lakes Initiative helped develop this common strategy document that outlined a number of goals around these 3 focus areas. And GLOSS was thinking about ways that we could also support the Smart Great Lakes Initiative that would help, kick off some momentum towards funding for this. And that was our 2021 mini grant program. So the call was for smart projects that ranged from new observing technologies to data delivery tool development, as well as engagement of new partners to fill gaps. And we received an overwhelming number of submissions, considering how short of a window it was open for. We had 80 proposals for over $6 million requested, and we had about a little over $1 million to fund. So we really had our work cut out for us, but we found some really great projects that we were able to support, including the Upper Maumee Smart Watershed pilot, as Jen mentioned, and as this whole thing is focused on. So we were really excited about it. There was universal support at GLOSS for this project because we are interested in expanding into the watershed and getting more information from the watershed onto our data platform. So this was a really great initiative, and they outlined very clear goals that were tangible. And really what it came down to was that this project was a really nice marrying of connecting data and consuming information. So they were going to be collecting data and making sure it was getting to GLOSS, which was important for us, and also making sure that information was being consumed by people like the stakeholders on this call. So it was being useful instead of just being archived and forgotten about. So as I said, we're looking forward to launching our Seagull platform, and we're really excited that the Defiance is part of the story. And I'm excited to hear the discussion and where it goes today and see the interest in this. So with that, I thank you. And if there's time for questions, I'll take any, but otherwise I'll be on until the end of the meeting. Thank you.
Thank you, Shelby. I don't see any questions in the chat right now. If anyone has questions for Shelby, go ahead and put them in the chat box, and then we can take them maybe after Ed's presentation, if that sounds okay, Shelby. You said you'll
Yeah.
be on the whole time, so
Yep.
we'll find a time to get those questions answered if there are any. So Ed, thank you for joining us. I think a lot of you might know Ed from his other work. Obviously with Limnotech, we have been, I guess, first introduced through another research project that's happening here in Defiance. I'll talk about that a little bit later. But we've had a lot of conversations with Ed about the monitoring work that Limnotech does in other communities and around the region. So I have a bio here, Ed, that I found online for you that I've been told that my microphone is not very good. So I'll let you just kind of introduce yourself rather than read this bio that I have. But I think you should be all set to do a screen share.
Sure. All right. Yeah, just let me bring it up here. Oops. Gotta hide stuff here. All right, can you see my screen okay?
Yep, that looks great.
All right, thanks, Jen. Yeah, hi everyone, Ed Berhamy. I had a terrible headshot that's way too old, so I just screenshotted myself here on this slide. But I'm a principal senior engineer here at Limnotech. I've been studying Great Lakes issues for almost 18 years now. I started originally focusing more on phosphorus modeling and really trying to use computer simulations to understand how nutrients move through the water system, but increasingly found there was very little data that is actually used to calibrate these models. We just kept supporting more and more organizations to collect more data so we could get better models. And I finally made a transition about 5 years ago to be majority supporting monitoring. There's a lot of technology, a lot of logistics in getting more data. I think we're used to the model of sending people into the watershed to collect water samples, which is really important, but just trying to see how technology and some automation, some lower costs can collect data even when we're not there. So I think this whole project here highlights, I'd say, the cutting edge of what we can do on an operational basis. We'll talk through a few of the, I guess, hiccups that we've sort of seen and when we try and push lab instruments out into the field. But I did want to acknowledge the team that supported getting real-time nutrients on the Maumee River in Defiance. Greg Cutrell, Alicia Ritzenthaler, and also Vince Kelly from Green Eye Science. This is really his technology that we'll see. We've pushed the application to it to get it, running inside of a water treatment facility. But it's the chemistry we're using isn't new. And I did. Oh, let me jump ahead. I was trying to figure out my order of talking here, but just to jump into what is a new lab. This is really an autonomous wet chemistry analyzer. So it's using the same chemistry we see in benchtop instruments, and it's running it out into the field. So it takes chemical reagents that are housed in IV bags that are on either side of the instrument, and it uses this syringe with the actuator valve to determine which bag it's pulling from. And there's a very precise program which can, down to the sub-milliliter range, measure how much reagent it's pulling in, sample distilled water, and running it through the detector. So this technology has been available for a while. There's the Cycle P is an instrument that does this same technology, but what we've sort of overcome with this smaller production volume instrument is it's an open chemistry recipe. We can tune our reagents. We can pick different analytical methods to run on this. We can also run multiple analytes using different channels and different detectors. So it really allows us to have a sort of Swiss Army knife approach to what nutrients we want to monitor, what frequency, what chemical processes. So it kind of is an open source or open platform for nutrient sensing. Not shown here is a Raspberry Pi, which is a open source Linux-based computer which controls and operates this. So it's really the, I'd say, state of the tech in terms of intersecting with chemistry and intersecting with water quality. So there's a lot of details we could go into on how this runs. I know our Defiant team we've been asking a lot of questions about this, what chemistry, what reagents, how to keep it running. So we can dive into that a little bit as people have questions, but just know this is a multi-team collaboration that's really taking some research operational instruments into a production environment like a water treatment plant facility. And I already walked through most of this, but just know kind of the brains of this instrument is this control valve, which determines what port we're pulling from. And it sort of allows us to work with different reagents, different cleaners, which help us keep the tubing and the detector clear, which is something we just struggled with in Defiance with how turbid the water is. Just to kind of point out, I mean, this is a lab instrument that we're trying to run in the field, so to say. So it's just like any chemistry instrument, we kind of got to watch for things that are fouling our instrument. Here we can see these are just some snapshots that Greg captured from getting a leak in the syringe, tubing that gets discolored from either very high nutrient concentrations or sediment that can get commingled and stain some of the tubing, and also just biofouling on our intake. So, despite all of these challenges, I think we've been able to get a good data set, kind of know how to tune the instrument and work with the water quality that we have. Just to give everyone a visual, this is the Maumee River right off of the Defiance water treatment plant here, the drinking water treatment plant. So this is river water going by, and there's a pump station that we're at here. So our goal is to get this river water into our analytical instrument. And I really want to thank the Defiance water treatment plant folks. This is the best setup that I've seen. What's been really nice about this is it was designed with online real-time sensing in mind in terms of getting water into a protected building. So you can see we brought river water in. There is a settling or a cyclone basin here that we see on the left. We can see that we're drawing a filtration. It's kind of like a fish tank air stone, drawing water into our small tubing, which then goes into the instrument. This cyclone basin also hosts the YSI, so we can get a real-time signals of turbidity, conductivity, temperature, oxygen levels. So again, we're trying to take this river water, steal it from the river, bring it inside, and get some measurements on what's happening and send the water back out to the river. This is just a visual of, you can see the Maumee River's out the window. We've got the cyclone basin here that pumps water in and then lets it drain out. You see our nutrient analyzers and our nice protected case here where all the reagents and the tubing is. The center photo shows our scientific data logger that's helping connect to the YSI, and also take some other measurements for measuring temperature in the building, temperature of the water. And then you can see our Raspberry Pi instrument here, which is really the operation of these 3-channel units, 3 single-channel units that are running 3 different analytes. Also a little bit of a power block and some RS-232 stuff. So it's been a really great experience for us to work inside the water treatment plant facility. I think it's good when people know how to have an operational environment, power, data, and getting water into the instrument. So I think water treatment plants, if there's any recommendation I have, is to keep partnering with water treatment facilities around Ohio. They have such a great resource for staff as well as facilities to house our environmental monitoring equipment. Again, just another photo with the door open here. And these are the 3 channels that are running about every 2 hours, I believe. So every 2 hours, we're drawing a volume of water from that cyclone basin in, and the instrument is doing all the chemistry it needs to, and then running that chemical sample water through the detector, which is the black box there, and we're getting a fluorescent signal, colorimetric signal to be able to measure the concentration and compare it to standards. There is an onboard standard here, so we're able to really understand any comminglence or drift or chemistry problems. So I think having an onboard standard run every 2 hours really helps us get accurate data from these instruments. Just to show you the dashboard, our team sort of set this dashboard up. There's about 50 different data streams coming from this Defiance site, between the continuous water quality measurements as well as all the analytical and diagnostic information for those nutrient channels. So we have a lot of information. So there's sort of a project dashboard we've set up, which allows us to at a glance see the data that we're sending, that are I'd say the real parameters, like the calculated concentrations of the there's actually 2 pages here that didn't quite fit, but and then there's not shown here as a whole dashboard for the each nutrient analyzer and understanding all the diagnostic information. Just to give you some representative data of what we've seen in this system so far, this is just looking back about the last 30 days. We can see we've actually started to see some chlorophyll spikes in the Maumee River, which isn't surprising. As water temperature rises, we're getting some probably some spring diatom blooms, or some just some I call winter algae. Oxygen has been very well oxygenated, which isn't a surprise. And seeing some diurnal signal, we're starting to see a slight diurnal signal, which would indicate the presence of algae as well. We can see turbidity. We had a high flow event flow through the system here in late March. You can see turbidity spikes. And again, water temperature is hovering around that 10 degrees, 12 degrees Celsius. Just zooming in on the nutrient concentrations, we've got dissolved phosphate, nitrate, and ammonia. And the focus of this project has been ammonia. I won't go into too many details, but it's a difficult thing to analyze. That's been the trickiest for us. We originally chose a high sensitivity detector, and I think that was probably a mistake to start. I know we're always concerned about accuracy in this lower level, but we ran into some issues with turbidity being high and really running into troubles with fouling up the detector. We just recently switched. I want to thank Greg for helping to troubleshoot some chemistry and some fouling issues, and also working with the plant folks to just help us get this system online. I mean, it came online in January, which, freezing conditions, challenging water quality, and we've really seen some really big events come through. So I think we've gotten a very stable measurements now in the last several weeks since we switched to this different detector for ammonia, and we've had decent, if not sort of 100% success with the phosphate and the nitrate as well. And I think this is just showing the last 24 hours. So I think what we're really moving towards is a real-time decision-based platform where plant personnel can at a glance get a look at conditions in the river and what's the quality of water coming in, and hopefully we'll hear more from the plant folks. Where do decisions start being made with this new data source, and what are we going to be watching for as this project continues? I think we again, just got this equipment online and really working through some of the bugs of installation, how to get the water in, to keep the pumps running, monitor conditions, go from freezing environments to high turbidity environments. So I think the summer is going to be relatively quiet for us in terms of the system. We'll see much lower flow conditions on the Maumee, and it'll be interesting to watch the nutrient concentrations. I think Jen really highlighted how Defiance is kind of the heart of the Maumee River. You know, you can really see all the tributaries flow right to Defiance and then head right down the lower Maumee out to Lake Erie. So the data that we're monitoring here is a really good snapshot of water quality on its way to Lake Erie. So with that, I think I'll turn it. Oh, I just had one quick glance at the sort of all the diagnostic information we can get from the instrument. So, you know, I think it's really great to be able to sit at our computers here in Ann Arbor and log in and understand all the diagnostic information with that nutrient sensor. So, you know, while we still are relying on wet chemistry, I think this is a really good method to monitor nutrients, and it's sort of the best available technology. Just to jump back to my beginning slides, I did want to point out that we have this same technology installed at a wetland site in Defiance. There's actually 2 instruments running right now at a treatment wetland site where we're trying to reduce phosphorus through a constructed wetland system. We're also have supported Ohio State University monitoring nutrients in Delphos, Ohio at their water treatment facility. Also supported Bowling Green State University with monitoring nutrients under the Sandusky Bay Bridge in Sandusky Bay, and worked with the Ohio DNR and Heidelberg to install some of these same instruments in Shallow Run and Potato Run, which are agricultural streams, and Old Wood Creek. So with that, I'll turn it back over to Jen or take any questions.
Yeah, I don't see any questions in the chat right now. We did get one question that I was going to address. Tom Denbo asked a question. I think it went to the group. Are there any other Lake Erie watershed-based communities participating in the project? So I'll let Shelby primarily address this question, but I did want to say that we are not, this particular grant is really just with just Defiance, Ohio. You know, we're obviously sharing our information up to the cloud with the GLOS, the Seagull platform, but we do work closely here in Defiance with City of Fort Wayne, Indiana, with Maumee Watershed Alliance, St. Joe Watershed Initiative. So we're working with them on some data collection and monitoring of the tributaries, but not specifically with this project. So we hope to see that expand in the future, and we've been Kevin will actually talk a little bit more about that in his panel discussion. So I'll let Shelby answer that question, and then we'll transition over to Joe Ewers, who's going to moderate our first panel. So Shelby, I don't know if you want to address Tom's question from your perspective.
Another watershed in Ohio, we're funding Heidelberg. So Laura Johnson's on the call. She's the PI for that, to install to turn a number of their stations into real-time stations, and we'll be also providing that information on our site. And then this isn't watershed based, but the Lake County water treatment plants also received some funding from us to install 2 sondes in their water treatment plants. So we'll see an increased monitoring along the coast as well.
Great, thank you, Shelby. Joe, I will pull up just a second here, and I will pull up. You did a great job with covering the dashboard and the photos of the equipment and giving a really good overview of the actual physical installation and how that works. I will go ahead and put the link to the dashboard. Ed or Limnotech folks, if you don't have a problem with that, we're still working out some of the bugs, so everybody keep that in mind, but I'll put that link in the chat box if folks are interested in taking a look at the dashboard. Joe will probably talk a little bit more about that, but he's our assistant superintendent at the water treatment plant, and he's been really kind of the main contact person for Limnotech. So I'll let Joe introduce himself a bit, and then he will introduce our panelists as well.
Thanks, Jen. Again, I'm Joe Ewers, the assistant superintendent at the water plant. My role in our endeavors is to facilitate sampling and analysis on our raw and finished water. And along with many others, Jen and Richard Krieger and Chad Zedzkowski from the Ohio EPA specifically helped draft our city's source water protection plan revision in 2020. I'd like to give a couple shout outs before we start our panel and I introduce the panel. As Mayor Mike opened, I'd like to reiterate and thank Jen for organizing the event and everything else that she does behind the scenes to help us get to the point where we've gotten to today. And as Jen mentioned at the beginning of her talk, we'd like to give gratitude and thanks to Gloss for awarding us the grant and assisting us in getting this online equipment going. That's kind of been in the works for over 12 years since Adam started mentioning it when he got into management here at the water plant. So without further ado, I'll introduce our panelists. Adam McDowell is superintendent here at the water plant in Defiance. The Class 4 surface water plant is located at the very end of the Upper Maumee watershed. He has been employed with the city for 31 years and has worked and is licensed in both water and wastewater. He is also currently working on obtaining a degree in project management from Northwest State Community College. After the city of Defiance installed its 74-acre reservoir in 2008, Defiance was thrust into river water quality issues more than ever. The effects of excessive nutrients are compounded in the clear, warmer conditions the reservoir creates. This leads to aggressive blooms that occur quickly and affect water quality significantly. Adam's involvement in this project has been primarily driven by the need to protect the reservoir quality. I'm going to introduce all three of them, and then I'll have them kind of give themselves a few minutes to talk about themselves. Bruce Cleland is our second panelist. He's a senior project manager with over 40 years of experience in water quality monitoring, modeling, and watershed planning. He graduated from Michigan State University with a Bachelor's of Science in Engineering Sciences and from the University of Washington with a Master's of Science Education in Water Resources Engineering. Prior to joining Tetra Tech, he worked for the US EPA, where among many other things, he provided capacity building assistance to states, local communities, and EPA regions across the country with a focus on connecting TMDLs to implementation. His recent efforts include work with Defiance to examine data in the Maumee and explore solutions related to the city's water supply concerns. He has also assisted communities in Ohio, Indiana, and Michigan in their efforts to develop meaningful watershed implementation plans. An outgrowth of this work is viewing solutions to water resource concerns from an agricultural perspective. He is particularly interested in turning the wide range of water resource data into meaningful information for producers through an integrated approach that considers a relationship between farm economics and stewardship. Though residing in Washington State, Bruce grew up in Southwest Michigan and remains deeply interested in the work to address the array of water quality concerns in the Great Lakes region. And our final panelist for this group is Bridget Moneymaker. She works for the Ohio State University Extension and covers Auglaize, Mercer, and Allen counties, engaging farmers in new production strategies, technologies, and best management practices to improve fertilizer use efficiency and farm profitability while promoting soil health and reducing nutrient and sediment losses within the Western Lake Erie Basin. She holds a Bachelor's of Science in Environmental Science from the State University of New York College of Environmental Science and Forestry, and a Master's in Climate and Society from Columbia University. Bridget previously worked with invasive species as a national park ranger with the Great Lakes Restoration Initiative and a project lead for NASA Develop, a division of NASA's Applied Sciences program that addresses environmental and public policy issues through NASA Earth observations. So with that, I will turn it back over to Adam for a few minutes and let him kind of give a snippet of himself on this.
Okay, well, I'm going to take my time here to talk about why this has been a big deal for Defiance and why what's driven us in this project. We have, as Joe mentioned, go ahead.
Sorry to interrupt you. I want to make sure that you guys can see the screen that I'm trying to share. This is your slide. Is that up on the screen?
It is. It's showing both my slides though.
Okay, so I'm in the presentation mode.
Yep.
Thank you. I'll get it figured out. Thanks.
That's good right there. Okay, so like as Joe mentioned, since I come into management especially, we've had a real issue with the river, and the river's been a problem for a long time, but the Maumee is kind of a strange character up here because of Independence Dam. It kind of creates a weird body of water up here. But as Jim showed that earlier, the watershed map, it's misleading when you look at it because it looks like the Maumee watershed is actually really small compared to the Auglaize, and it is small. But the problem is that it's really prone to a lot of nutrient issues. And one of the drivers for this project for us is we wanted to illustrate kind of that a lot of those nutrients are already in the Maumee before the Auglaize, before the Tippin ever even hit it. And so it's kind of a section of the river that doesn't get a lot of attention sometimes, but it's really problematic up here. We've seen, and in my first slide here, I'm just showing you a little bit about, these are kind of, I just showed two algal blooms here. One of them, the first one was in 2016, which was probably our most famous one. Some of you were probably involved in it, which was a Plankothrix bloom that happened, and we ended up with toxins in the Maumee. We actually ended up with a no contact being issued on that river, and it was, we're talking late May, and algal toxins hit. They actually went over 19. They were in the low 20s at one point in time. But if you look at the numbers, you can see that those numbers are crazy high. And you see that not only were they high in Plankothrix, but also in Planktolingia. And so the total counts were just insane. And while I point that one out just to kind of, and at that, oddly enough, 2016 was a pretty mild year in Lake Erie because we bloomed up here and we used a lot of those nutrients up here. 2017, just October of the next year, was, you see some pictures at the bottom, a really gross looking river. Now that was not in the cyanobacteria, but it was still a ton of organic mass. And, and we see all kinds of algae. We see Euglena. We had a really bad bloom the same year in 2016 where you looked like you could walk across the river, which was Euglena. We see Anabina, Planktolingia, Limnetica, Aphanicapsa, Plankothrix. Plankothrix is our biggest problem most of the time. I have a little picture of it there. It doesn't look that scary, but it is a toxin producer. And the neat thing, I guess, about Plankothrix is it doesn't need sunlight. And we see wintertime Plankothrix blooms. Actually, this time last year, the rise in chlorophyll right now is caused by diatoms, but last year at this time, we were in a Plankothrix bloom and about 25,000 cells per milliliter. So we didn't have any toxins with it, but we had a pretty significant Plankothrix bloom, and we see those early spring with super muddy water. But if you go to my next slide, the reason why the river is such a problem . Okay, the reason why, and I put this at the top, so what, the river's always been like that. And I hear that from the public a lot. They're like, oh, the river's always been gross, or it's always been this. And we hear that. But in 2008, the city built a reservoir, and they had to build it because of the frequent nitrate violations. And whenever we built the reservoir, it changed how we have to interact with the river, because now if we bring those nutrients into the river and then we allow it to clear up and heat up, we end up with very, very significant algal blooms. So because the river is what it is, we're really only able to pump about 160 days a year on average, which we run a very, very low reservoir level a lot of times. Our reservoir is about 18 feet deep when it's full, but it's pretty common for us to be about 10 foot deep in the middle of summer, which raises the temperature even worse, gives us even more troubles. And then I added this at the bottom, and it's, the effects are starting to get expensive. Our outside costs, if you look in 2021, we see almost $50,000. We had a Planktolingia problem last year, which is not a toxin producer, but at the same time, it creates massive amounts of organics. Organics matter causes us to violate even worse on trihalomethanes and disinfection byproducts. And that problem has led to our granular activated carbon project, which is a $10 million project that has just went online because we've been in violation. So it's expensive to treat this stuff on this side of the equation. But that's really what's driven us is the effects of the river and how it's affected treatment. Ammonia for us has been a big driver of that. And most of these algae bloom on are nitrogen fixers and bloom extremely fast with ammonia. So that's been the call for us with ammonia through the project. So that's where I'm at.
Thanks, Adam. And again, we'll get a chance to dive into some more information if we want here in a little bit. I turn it over to Bruce and have him kind of give his little part on what he's been doing.
Okay, thanks, Adam, for that introduction, and Joe for your introduction. And the one thing I would like to add is, what a pleasure it's been to work with the folks from Defiance. I had the opportunity to start working with Jen about 8 years ago. Actually, we had a long conversation on a canoeing the Upper Maumee through this problem stretch here. It was shortly thereafter that I had the opportunity to work with all the department heads and especially Jeff as city administrator, even though, Jeff's responsible for about everything under the sun. He has really been a big picture thinker about the Maumee Basin and Western Lake Erie and data and how to use it. So anyway, as Adam said, a lot of the focus, where I got pulled into this part and looking at the Upper Maumee is years ago, Adam kept telling me about this problem he had with ammonia. And as Joe had indicated, I've worked all over the country. Some of my coworkers, former coworkers at US EPA used to joke with me. They said some people, birders keep a list of birds they've seen. They said with you, it's a list of impaired waters that you've worked on all over the country. And this ammonia situation is something that I hadn't quite seen like that before. My reaction to Adam was, hey, ammonia, turns to nitrate pretty quickly. But so he and Joe started sending me the data. I started taking a look at it, drilling into it in depth. I tend to like to take a look at all this other information too. I will highlight some of the work that Laura Johnson's been doing. I'm glad Laura's participating in this. As Laura knows, I've kind of milked their data every which way. And the same thing with Kim and Donna from USGS are on. I am constantly on the USGS site downloading that. So one of the things I've been doing for the past few years is comparing, Joe and Adam's water treatment plant data with this whole range of other data, and also looking at the broad range of different parameters too. The one thing about ammonia is that, as Adam has told me and I've observed, is the exceedances are unpredictable. Like when you look at nitrates, for instance, usually you see those high levels occurring in late April, May on through June when you've got the fertilizer going on in the fields. With ammonia, it's just kind of hit and miss. Jen and I have had some conversations with some of the producers. As Joe had mentioned, I've been doing a fair amount of work with the agricultural community in Indiana, Ohio, and Michigan lately too. So I've had conversations with them trying to understand some of this. But what we've noticed the last couple of years, and especially last year, is that there was a decrease following the Toledo water situation. There was a lot of sensitivity about nutrients going on. So we saw a big drop when you look at the Defiance ammonia data in 2014 to 2015, but the last couple of years it's been going up. So in addition to the USGS and Heidelberg data, I've been also taking a look at the city of Defiance has added some sites. They're on the map here. A couple on the main stem besides at the water treatment plant, one at the Cecil Bridge, the other one at the Bend, and then a couple of tributaries as well. And Kevin Connor and his staff have been working on that. USGS has also added, in addition to their sites on the main stems, They've got a site on Platter Creek and not shown here on the Indiana side is Black Creek. On the Indiana side, there's a lot of data coming out of Fort Wayne and Allen County. And then recently I've been taking a look at Bridget's data, and she'll talk about that too. So anyway, what we were really interested in is trying to understand, what was going on with the ammonia spikes, but also looking at the other parameters too. And that's why we were interested in getting the real-time data to help fill that gap. Joe, why don't you hit the next slide? Or whoever's controlling the slides here.
Yeah, Bruce, that's me. I'm working on it. Let me figure out how to get your next slide.
Okay.
Oh, went too far. Oh, now I got to figure out how to go back. There we go.
Okay. So anyway, in terms of the real-time data helping to fill the gaps, what it's enabling us to do is gain a better understanding of timing and frequency of the source water concerns. The one thing I forgot to mention when the map was up, and don't put the map back up, is that USGS has done a nice job of bracketing the major tributaries on the Maumee. But one of the issues we have is on the upper Maumee. That site is at Antwerp, which is the Indiana border. The site on the Tiffin is up at the Defiance, Williams, Fulton County line there. So what we've really been missing is what's coming in from Defiance County, both on the upper Maumee and on the Tiffin. So that's one of the main reasons why we've been doing the additional sampling and why we've really been interested in filling some of these gaps at the water treatment plant. One of the things that we plan on doing, and as Adam has said, both of us could go on for hours talking about everything we've been seeing, but I know that we're really looking forward to using this data to proactively work to explore solutions. I know a lot of the focus on Western Lake Erie's been on phosphorus, but the nitrogen issues really offer some unique opportunities, especially when we're working with producers. The elevated nutrient levels that we're seeing in the river really represent a loss of the field. I know Michelle Seltzer from Michigan's on. Hi, Michelle. I haven't talked with you for a while, but some of my focus here has been work I've been doing with Michelle's coworkers up in Michigan. I spent a fair amount of time working with Hillsdale County, in particular, the Conservation District. I still say DEQ. I guess Eagle is the end term for the last few years now. But working with them to look at the connections between water quality and the resource loss from the field. So I really appreciate some of the work that they've done. Plus, in addition to what USGS has been doing in the rivers, they've got some edge of field sites that they've installed too, one in Hillsdale County, one over in Allen County, and we've been using that data. So the whole idea is and Jeff has always hammered this at me for years, the years that I've interacted with Jeff Leonard and Defiance, is how can we basically turn this information, all this data that we're collecting, and start working with it to gain solutions. So one of the things about these elevated nutrients, and I've heard Chris Winslow and others talk about, besides, the concerns that we're seeing in Western Lake Erie and the river, that represents a loss of resource from the field. So anyway, with all this data that, what I've been doing is looking at it every which way, both in terms of daily patterns, seasonal patterns, and then year-to-year variability. And how can we use it to recognize and incorporate some of the different innovations that are going on, especially on the agricultural side. That picture at the lower side is one I grabbed last year in Hillsdale County at their nutrient management field day, where Jay Williams is starting to use drones to apply nutrients out in the field. So, and I know all of us could go on and on about the different innovations that we're seeing. So with that, I will turn it over to Joe and Bridget to talk about their work.
Yep, thanks, Bruce. And again, this is Bridget Moneymaker from the OSU Extension, and she's going to give a little brief summary of the project that she's been working on and the staff that she works with has been working on in Delphus. So take it away, Bridget.
Good morning. I just wanted to jump on and give a quick summary of the project. I'm working with Ohio State Extension. We have a team of water quality associates and extension spread out along the Western Lake Erie Basin. I'm concentrated here in Allen, Mercer, Auglaize, and also Van Wert County, working in the upper Little Auglaize watershed. We have one of those new lab analyzers on the Little Auglaize River in the Dry Fork watershed, which is a Huck 12. And we focused here because these watersheds have, according to the 2020 Domestic Action Plan, have high annual phosphorus yield, and upstream watersheds have cyanotoxin and nitrate impairment. So we are working with the Delphus wastewater treatment facility to monitor this location with that new lab equipment. And then personally, I do weekly grab sampling at 9 locations up the watershed. And we're hoping to use this information to inform not only efforts that the wastewater treatment has in treating their water, and hoping to identify some locations in the watershed with producers where we can add some best management practices to improve water quality in the ground, and also combine some other projects with OSU faculty, including remote sensing, some modeling, and nitrogen efficiency, manure, side dressing, using these projects in that watershed, and then having that real-time monitoring and grab sampling to hopefully get a better picture of some of these conservation practices' impact on that watershed and then Lake Erie as a whole.
Thanks, Bridget. I think at this time, I'm going to pull Bruce and Adam and Bridget back into it, and we're just going to take the next 15 minutes or so and just kind of talk about what we've been doing here at Defiance, how Bruce has helped us, and kind of relate it to what Bridget and Delphus is doing down on the Little Auglaize. So I'll start with, we actually got introduced and kind of hooked up with Bridget in Delphus when we were just kind of trying to figure out what type of equipment we wanted to use for the online monitoring. And I don't remember, Jen can correct me if I'm wrong, but it was kind of one of those, we heard it from someone and we're like, oh, hey, let's go check out Delphus. And it ended up being like the perfect setup for us. It was like, wow, where has this been for the last, 5 months while we decided what we wanted to do? And so I guess my first question, and I think Bridget, you kind of covered it a little bit, but was it Delphus or it was OSU Extension that initiated the monitoring efforts where you guys are at there?
I think that was decided before I came aboard, but I know there was some collaboration with our director, Heather Raymond, who works for Ohio State's Water Quality Initiative, in addition with the wastewater reaching out and having some of those issues. And we were able to connect the dots with some grants to get some targeted projects going there. And that's how I came on board.
Awesome. Well, and Bruce kind of joked a little bit, but we have a weekly Zoom call with several of us that have been working on the VOS project, and Bruce and Adam can legit just kind of go on for hours and hours if you allow them to. So Adam kind of touched on how we got started here, but if Bruce and Adam would kind of just where we started with why we were starting the monitoring efforts and what we want to do with that data, if you guys can kind of touch on that.
I can start with this, Bruce. Ammonia has caused problems for us with, even before the reservoir, with chlorination. And if we get any amounts of ammonia into the reservoir, into the river, ammonia wipes out chlorine, it combines with chlorine at a very, very high rate. So we would have issues before the reservoir where we could almost not dose enough chlorine to get a residual in the system because of high ammonia spikes. The problem is now is that if we get ammonia into the reservoir, we are stuck like that for months. It doesn't convert in the reservoir into nitrogen. It stays as ammonia for whatever reason, but we can be stuck feeding massive amounts of chlorine for 2 or 3 months at a time. We've seen that, which the problem is with ammonia in the reservoir, we get horrific blooms. They really, some of the cyanobacteria bloom extremely fast with ammonia as a food source. So because of this, we have to, anytime we're pumping water to the reservoir, we are running ammonias almost every other hour and every 4 hours for sure on shift, just to make sure that we don't run into a spike of ammonia that pumps into the reservoir. We end up contaminating the reservoir. So because of that, it takes a lot of manpower. So we've been looking at online automated ammonia monitoring equipment for a long time. And that's been, Jen's heard that and everybody's heard that from me. It's been my soapbox for a long time. But we have to be able to stay away from ammonia, particularly because of its short-term effects. It's extremely aggressive for us. But this was an opportunity, this project was an opportunity to get that ammonia meter and then also just grab a lot of data. There's just so much data coming off the river at the Upper Maumee right now. And it's so useful in treatment for us. And then it's also, I think it's got a long-term benefit of being able to benchmark anything done on the, upstream of us.
Yeah, I'll add on to that, Adam. I mean, I've been, in addition to taking a look at what's going on in the water treatment plant with, like phosphorus and nitrate, you can there are patterns that you see over the year and associated with flow conditions that you can kind of explain. Like I mentioned with nitrates, they tend to go up when the, fertilizer is going on the field and you've got runoff events. Phosphorus gets to be a little interesting too, especially the total phosphorus, and Laura will probably talk some about that, is in addition to what's coming off the fields, we've got a lot of legacy issues. But with ammonia, it pretty much reflects what's going on, both coming off the fields and as Adam says, coming down his way. As I mentioned, I've been doing a fair amount of work with producers in all 3 states here, but especially the last few years in Michigan. And I don't mean, I grew up in Michigan. I've been back and forth to Michigan quite a bit until the pandemic hit, dealing with aging parent issues, which is, why I've been able to spend so much time with Defiance. But a number of the producers that I've worked with in all 3 states, they're interested, like I say, not only in being good stewards, but also, the nutrients coming off the field, that's money out of their pocket. Jay Williams, like I mentioned, up in Hillsdale County, makes a real point of that. And that's why, he's worked with USGS to put some of these edge of field sites on there. And that's one of the things, like that site, plus the one in Black Creek and Allen County on the Indiana side, coupled with the other USGS in-stream sites, the small tributaries, is you can really start to take a look at the land to stream and then into the Maumee River pattern there. So what we've been trying to do is take the data, especially that Adam and Joe's been just great about feeding me the data as fast as I asked for it. And not only that, but the rainfall data as well. And with the USGS flow and their water quality data, start to take a look at some of these relationships and then how do they connect back to what's going on in the land. So that's kind of, and Jen and I, besides the Hillsdale County folks, Jen and I have had some conversations with other producers too. And some of them are, they're aware of the phosphorus issue. The ones I've talked to have been totally unaware about the nitrogen issue, the nitrate or the ammonia issue especially. And it's of concern to them as well, because if it's showing up in the river, that's what they're losing off their fields. So anyway, that's what we're hoping to gain out of all this. Bridget, I don't know if you want to chime in because you've been doing a lot of stuff. I forgot to add, I've been, Bridget and I had some e-chats starting last fall, and I've been able to grab, the data coming out of the Delphos site too, which has been very helpful, especially the nitrate and the phosphate data.
Yeah, I can reiterate several points about how we're hoping to use some of this information. Specifically with us, with OSU Extension, we are, like you guys mentioned, going back to those producers and kind of we're able to show them a more targeted look at what's going on in this watershed and kind of leverage that into either collaborating with some edge of field sites, on farm trials. We're currently working with some watershed management plans in this area, so we're using some of that data plus some of our own modeling to highlight some of the locations that we think would have the most impact for some of these people. And then that will be able to, like you guys mentioned, go back into their own farm and increase their efficiency and profitability as well, and not have to worry about what's coming off their fields into the lake.
So, and that's really awesome on our end, because, you know, we've always kind of been worried, you know, we keep beating our heads against the wall, trying to make sure we're treating the river the way it is. But you know, the cool thing about this project is we got introduced to Bridget and OSU Extension, and we've always known OSU Extension, but we know that they're actually putting it into practice. They're taking that data and using it. And that's what we need, because that'll help. I mean, not necessarily the little Auglaize, but, you know, Upper Maumee. But when people start actually using that data to help themselves, it helps them, but it also helps us. And that's what we really need. We need results that make.
Joe, you've turned into a statue. I'm gonna turn your video off and see if that will help.
Yeah, that's a problem. I'm going to turn my video off too. I'm on a rural DSL connection, and the video kind of screws things up.
Adam, do you want to pick up where Joe left off? I think we know where he was going with that.
I'm not sure where he stopped because I froze too. That's the shame of
Well,
being in the same building.
Yeah, I think, oh my gosh, he must have dropped off completely. So, well, I think what he was saying is that, and he was making a point that I wanted to reiterate, that, you know, one of the reasons we had this workshop, and it was one of our deliverables in the grant, right, was to engage our stakeholders and to understand not only, you know, this data is helping us, but how can this data help others, and how can we, you know, obviously we're going to share it with GLOS to the cloud, but the data that we're collecting, we want it to be useful for others as well. So I think that's where he was going with that. Adam, if you want to jump in, we'll see if I can get Joe back in.
You know, the other thing I'll add too is, and I kind of mentioned this before, is we're hoping it benchmarks progress. So the thing is by having real-time data, any changes that are made in the watershed, we can actually see what they did and long-term. So, you know, the goal for this project isn't for us to run it for a year and see what it looks like. The goal is to run this for a very long term. So as we see edge of field stuff done, as we see different things happen, what does it affect inside this watershed? Not to mention, you know, when we look at things like ammonia, are we seeing effects of ammonia sulfate? Are we seeing things like that? What happens on a wet year? What happens on a dry year? What happens? So we can actually, you know, we can actually get a better feel for what's going on. Typically for us, the worst years in the river are dry springs. They're also the best years for Lake Erie typically, because we're not washing the nutrients down to Lake Erie. They're all just blowing up here. So, you know, climate change is affecting those things. All those things have an impact. And this allows us to turn around and see this watershed as it is. And, you know, we can really kind of get a feel for what's going on. Most of this watershed, almost all of this watershed is agricultural. And so we're able to see the effects of what they do and how those changes, how they really do affect what's going on here. And
yeah, Adam, what you said about the flow and the climate, the one thing you and I have talked about too, is it's going to be interesting this year with fuel and fertilizer costs just going up very, very high, to see how much that changes things too.
yeah, absolutely. And, you know, on top of that, there's also the effect of nitrification in the fields. How is it affecting, you know, the soil temperatures? How is it affecting everything else top to bottom? I mean, are we seeing ammonia the way it is because it's not being retained in the fields long enough for it to be effectively transformed to nitrogen? So, I mean, there's a lot at play there. And the nice thing about the geographical location of this setting is it really funnels down what we're looking at as far as data. It gives us a much better view. The Auglaize goes through a lot of areas. You've got wetlands areas. You've got, you know, it's very big, but this one is really focused and really centralized.
Ooh, I'm back. I'm not really sure what I missed.
All right.
But,
Jeff, you're back.
I guess I missed a little bit there, but where do we go from here as far as source water planning, using the data? Like, is there more that we can do? And is it more communication with OSU Extension and groups like that? Is it we continue the way we have been? Obviously, that's not what we want to do. We're hoping that using this data and more people having access to this data, hopefully throughout other places as well, not just here or at in Delphus, but is there more opportunity for things like this in groups? Bridget, I'll start with you.
Yeah, I think one of the benefits is, especially for OSU Extension, because we're trying very hard to put some of this information back into the community to be able to supplement some of our own projects, and being able to go out and show producers for almost the last 2 years that we've had some of this high quality data in the region. And we've been able to utilize that, branching off for master's students have been doing projects in this area with our data. Other water quality associates have been brought on to projects where we'll be sampling discharge in this location and then be able to supplement with our data. So it's been really great, not only to show the community that we're doing the work here to be able to give them very science-based information about what's going on in this location, and then using that to help them address their own fields, and then hopefully have more confidence to work with us in the future for some of these more intensive or long-term conservation projects.
And then Adam and Bruce, either one, I mean, we talk about the data, we use the data. Now, what do we do? Do we continue to push it out? Do we hold more meetings? You know, where do we go from here on our end?
Well, not to repeat myself, but again, there is a lot of interest I've observed with the agricultural community, you know, and what's the relationship to what they're doing. And that's why we're seeing, you know, an increase of some of these edge of field sites. And, you know, each field's a little bit different. Each producer manages things a little bit different, but it's to try and understand some of these patterns that we're seeing in the river. And again, like I indicated, you know, what we're seeing in the river is field loss there too. And take a look at how we can connect that information to some of the more innovative practices that they're doing. I'd mentioned, you know, Jay up in Hillsdale County starting to use drone technology to do his nutrient application there. There's a fair number of challenges with that. I think we're all aware of, you know, basically, you know, farming today is not what it was, you know, when I was growing up. I mean, not only do you need to know the agronomy and everything else, you need to be a business person, you need to be an IT person, you need to be a mechanic, you need to understand GPS. So, you know, it's become a very high-tech endeavor. And I think that's why there is so much interest in some of this data too, is, you know, and then you get into the whole economics and the marketing side of it too. I mean, the producers I've worked with, they feel like they've got a target on their back, you know, relative to Western Lake Erie, but there's also the consumer pressures coming in too. I mean, if you go into grocery stores, you know, you'll see, hey, you know, this is what I'm doing to you know, stay sustainable and help the environment. So there's a lot of sensitivity on that side. So, I mean, my focus is connecting the water quality side and working towards the agribusiness side of it. And I know that Mark Zeller and Paul Carlson and I have talked about that. I see that Kayla Miller's on with Northwest State too. We haven't talked yet, but and Bridget and I have talked a little bit about this too. So anyway, connecting the dots.
Thanks, Bruce.
I just want to add, and Bruce, if you take a look at the chat, the question that just came up is probably going to be one best for you. You're probably going to have more experience with that. But, you know, the water plant's involvement with this really wanted us, it was kind of a hope that we could move from not just somebody who uses the water and complains about the water quality, but being somebody who's actively involved in narrowing down the changes that need to happen, help solve the problems. Because it's too expensive to fix these problems on the water plant side. You cannot continue to treat bad water quality, bad source water quality on this end. It's just not possible. Even if Lake Erie wasn't blooming, between us and Napoleon, Bowling Green, all the places that pull this water, it's just too hard to treat. And it has to be resolved. So, you know, for us, it was a chance to get involve ourselves at that level. More involve ourselves as not just a stakeholder because we're a user, but a stakeholder in the solutions. We're kind of hoping it would be an example for other people to follow, that to get into a level of it that we're not normally in. So that was my mindset with it.
Yeah, I didn't pay attention to the chat. I'm more focused on listening to the conversation, but you know, so what was the chat question, Joe?
That's well said, Adam, though. I mean, I think that's a good summary on our side for sure. The question is, Bruce, since loading patterns are different for NH3 and NO3, do you all have much speculation as to what that means for source management? Also, from a producer standpoint, more N moves as NO3. So how do you square that with the higher environmental concern in the reservoir? Are there trade-offs like we see with total phosphate and total dissolved phosphate?
Yeah, there's definitely relationships between the phosphorus and the nitrogen, but that's why in my slide I said, you know, nitrogen, I think most of the attention's gone to phosphorus, but I think some of the keys to solving all these problems are on the nitrogen side, and especially the ammonia. And as Adam has indicated, I mean, that's the stuff that moves more quickly through the system. It comes off the fields more quickly with, you know, other than phosphate, you know, with total phosphorus, like I say, you got legacy issues, but with the nitrogen, I mean, what you're seeing is what, you know, eventually you're getting there. And even though ammonia is yours and Adam's problem, it eventually converts over to nitrate, where it becomes Napoleon and Bowling Green problem. And I know I've had conversations with the folks in Archbold on the Tiffin. They pull out of the Tiffin and they don't see the ammonia issue that you guys do, but they do see the nitrate, and they put it into a reservoir too. And like Adam said, that, you know, with the movement towards these upground reservoirs, is that once you pull it out of the river into there, and you know, you've got the phosphorus, but you've also got the nitrogen, and you're getting these blooms in there too. So as Adam says, it's you know, there's an economic cost here on the water treatment side, and it's kind of like I was indicating with what we've been seeing with the ammonia, especially, you know, the nitrogen trends don't seem to be, they're stable at best. And in some years, depending on the hydrology and the climate, we're seeing like what we saw with ammonia last year. It's going in the wrong direction.
Yeah. Thanks, Bruce. I know we're running a little bit past time, so I'm not a very good moderator, but Jen, there was another question coming. I think I'll let Adam address that real quick, but I'll let him address it. I'm going to thank Bruce, thank Bridget, and thank Adam. And then after Adam answers the question, maybe even Jeff could tell Adam, just kidding, but then we'll end this portion of it, and then we'll let Jen decide if we're going to do a break or not.
Okay, well, the question came in the near future, will Defiance need a second and possibly a third upground reservoir? Especially since you're pumping the raw water into the current reservoir only 160 days per year. There's been a lot of discussion about that, and there's a couple problems. One is we're not really built to be able to move enough water whenever we can get it. So the problem is we only have the ability to increase the depth of the reservoir about 1 inch a day whenever things are whenever water quality is good. So we're going to have to increase the size of our intake. It was never intended to have to fill that fast. It was intended whenever the reservoir was built that we would have a lot more pumping days and we'd be able to just continue to add water to it on a regular basis. But that's not even remotely what's happened with the river. You do have to worry about how fast you fill a reservoir though. So there is limits on how fast you can fill it. So it's not like you just throw the biggest pumps in the world, fill it in 2 days and you're good, because you have to worry about the banks and whether or not it'll support that. A second reservoir has got some plus, but if I can't get good water to fill one, I can't get good water to fill two. So we already spent a lot of money on algicide, and that would be a problem that we would have still, is maintaining two is just that much more work. But it is probably going to happen eventually because of aflatoxins. Our GAC system though is a barrier for aflatoxins. That's the basis of that project, was an aflatoxin problem or solution. But I will say this much: when I'm spending $10 million on GAC, when I'm spending $8 million on the first reservoir to get away from nitrates, treatment costs go up. It's hard to continue to pay for projects to run from this sort of problem to start with. So eventually the debt is a real issue and rates are a real issue. So Defiance is not exactly a rich community. So we do have to have issues with that. It's expensive to treat water problems at the treatment side. It's much easier to mitigate it in front.
One other thing, Adam, your GAC does not take care of ammonia either, does it?
No, not at all. So, but it does handle the aflatoxins. So, and the taste and odor, because we end up, these blooms can produce bad MIB and jasmine issues, which we've had issues with that in the past, where they've lasted months because of big taste and odor producing blooms.
Thanks, Adam. Thanks, Bruce. Thanks, Bridget. And Adam, once again, for everything you guys do. Really appreciate it. Jen, all yours.
Yeah, well, I'm gonna push pause on the recording, give everybody, 5-minute break. I think we'll take that 5-minute time and then we'll get resituated and just start back at 10:40 if that works for everyone. Kevin, I think you said you're all set. So I'll pause this for about 5 minutes and then we'll reconvene.
Sounds good, Jen. Thanks.
Again. I know we've had some really good questions in the chat. A couple of comments and a couple of questions. So I'll let you go through your planned portion, Kevin, and then maybe a couple of these questions and comments we can hit towards the end of your panel discussion.
Absolutely.
Okay, thank you.
All right. So like Jen said, my name is Kevin Connor. I'm the assistant superintendent here at the wastewater treatment plant. I'd like to thank Jen and all of our speakers today for putting this on. I think it's a good event and I'm looking forward to the next speakers. So like Bruce kind of touched on earlier of our water sampling program we've been running here at the wastewater treatment plant since 2018. We started watershed sampling from May 1st to October 31st on 3 different creek sites. And starting in 2019 through now, we branched out to 2 creek sites and 2 locations on the Maumee River. One of the creek sites is Gordon Creek on site 313. There in the middle of the slide, and what's the other one? Antwerp is Zuber Creek that we've also been sampling for the last few years. We also take samples on the Maumee River at Cecil Bridge and the Bend Bridge. So we send technicians out in the field and we run temperature, pH, and dissolved oxygen. And we also bring back samples and drop them off at the water treatment plant. They run turbidity and nitrate. And at the water pollution control facility, we run ammonia and solids and E. coli. And then we send out total phosphorus and orthophosphorus to Alloy, to a contract lab to run. So that's what we've been doing here for the last 5 years. And that will lead me into our 3 speakers. So our first panelist is Kimberly Schaefer. She has a degree in civil engineering from The Ohio State University and has worked for the U.S. Geological Survey for the past 25 years. As a hydrologist, she has collected and published stream flow, water quality, and water use data. In 2021, Kim became the continuous water quality technical lead in the USGS water mission area, observing systems division, hydraulic networks branch. Our second panelist is Laura Johnson. She's the director of the National Center for Water Quality Research at Heidelberg University, where long-term monitoring of streams and rivers is used to examine the influence of human activities on water quality to help decide actions that lead to healthier ecosystems. Laura is best known for research examining the linkages between agricultural runoff and harmful algal blooms in Lake Erie. And our third panelist is Ed from Limnotech, who we heard from earlier. So I appreciate you all being on the call or at this workshop. And I will turn it over to Kimberly to kind of discuss what slides she's prepared and the work she's been doing.
Great, thanks, Kevin. Give it a second for the slide to come up. Thank you for the opportunity to join you today. I started out my career as a U.S. stream gauger and then began running continuous water quality monitors. Those are sensors in the streams, lakes, and wells that record 5 to 60-minute data for temperature, pH, specific conductance, dissolved oxygen, turbidity, nitrate, chlorophyll, and other sensors. And you can see on the slide there in the middle top, you can access this data through the USGS Water Quality Watch. You can just type in USGS Water Quality Watch to see where all those locations are. I've also been involved with the USGS Water Use Program in different capacities. There are some great USGS water use visualizations out there, and you can access them by typing USGS VizLab, and that's VIZLAB. Around 2014, Higher Department of Natural Resources and OEPA were interested in the USGS sampling for sediment and nutrients, computing daily concentrations and loads in the Western Lake Erie Basin. This network has grown over the years with the support of many additional partners. The cool work we do at the USGS would not be possible with our partners. Data can be accessed through the QR code there. You might also be interested in a journal article that was published recently. If you remember 2019, it was the year that it rained and it rained and it rained. And this article discusses what we saw in the data. In 2021, I transitioned to the continuous water quality lead, but I'm still co-located in the Columbus, Ohio office. We also have Donna Runkle in the webinar, who was the lead for the Western Lake Erie Basin project for many years, but will be retiring later this year. And I might direct a question to her if I feel it's more in her area of expertise. Stephanie Kula, Dennis Finnegan are the project leads for the Ohio sites. Ed Dubrowski is the project lead for the Indiana sites, and Bryant Smack is the project lead for the Michigan sites. Dr. Tanya Williamson is a research hydrologist, has been working with the data and spearheading multiple publications. We have a great group of staff in all three offices that help with collecting and processing those samples, computing stream flow, and computing loads. And if you have some additional questions about the project or a specific site, please let me know and I could get you in contact with the right person. So there you go. Thanks, Kevin.
Thanks, Kimberly. Laura, would you like to start?
Yep, happy to. I assume my slides are popping up next.
Yes, they are, Laura. I am so not used to doing this. So give me just a second.
Oh, that's fine. I can also share my screen if you prefer.
Oh, there we go. Okay, you're all set, Laura.
Perfect. You can go on and skip to the next slide.
Oh, that seems to be my downfall. Why they're not advancing for me. There we go.
You have to click on the PowerPoint before you hit advance.
Okay, gotcha.
And back one more.
To
Perfect. Yeah, we can stay right here. Great. Okay, great. So hi, everyone. So I'm Laura Johnson again. I'm from Heidelberg University. And at Heidelberg, I think we're probably best known for our long-term monitoring of streams and rivers. We monitor all throughout the state of Ohio, but I think we're best known for our work that of tributaries that go into Lake Erie. And so this is a map that I pulled from the expanded water quality monitoring report that Ohio EPA pulls together. It's hosted on the Ohio Lake Erie Commission website. And I really like this map because it shows not only our sites, which I changed into cute little H's because, you know, the Heidelberg H is a unique thing on its own, but then also it shows all of the USGS locations, both just exactly what Kim was talking about, the Ohio USGS, Indiana, and Michigan's. So I like all that. I will note that Oldman Creek is now, I think, mostly being monitored. They're doing the monitoring themselves, or they've got some new labs as well. I didn't include in this slide that we do have sensors at a lot of our sites. So sorry, Shelby, we did get a GLOS grant as well so we could get our data online in real time. So nonetheless, imagine there's a bunch of sensors here too. And this is just a reminder that the way we work, and USGS is similar, is that we're pulling samples using an automated sampler. Our method is that we're pulling 3 times a day, and we analyze either all 3 samples, the flow is up, or 1 sample a day at a minimum, and when we bring them back to lab. USGS does a similar approach that's more flow driven changes in terms of what samples they're analyzing for. All right, so you can go to the next slide. And so I think what people think of when they think of Heidelberg is probably this very specific figure showing the changes in concentrations of dissolved phosphorus from the Maumee River at Waterville over time, and how those changes correspond to the presence, the basically absence, and then the return of blooms to Lake Erie, which I think is obvious here. I'll note that for each dot here is the different year of data, and the line is the 5-year running average. If you get to the next slide, or what's the next? There you go, perfect. So then the opposite being total particulate phosphorus, which is the phosphorus that would be on the muddy particles, or in this schematic here, the ones that are trapped on that filter paper. We see a slightly different pattern. We see that decrease in particulate phosphorus through the 70s, through the 2000s, and not a whole lot of change recently. And that's because there's a lot of effort in agriculture to reduce soil erosion. That's sort of what we think has led to our dissolved phosphorus problem as well. But it's always nice to show that when we do have wide scale watershed efforts, that there are changes that come from those efforts. And then the next slide. There we go. And then I wanted to briefly show nitrate nitrogen, because I had a very strong feeling you guys are going to be talking about nitrogen some today. And so I wanted to show that our nitrate nitrogen data, you know, this is annual concentrations. They're hugely variable. It really has to do, just like Bruce was saying, on that, the combination of when fertilizer was applied versus when we got a runoff event. But what you do kind of see is that the trends, we tended to have slightly higher concentrations through the 90s. There was a fairly precipitous decline in nitrate nitrogen from the 2000s to about 2010. And since then, we've been a little bit lower than where we were in the 90s. A lot of that is attributed to better nitrogen use efficiency on farms. We're getting more yields, but not applying all that much more nitrogen fertilizers. And I think, I mean, I could keep going for a minute. Yeah, we'll flip through these slides fast. I tried to fit everything in 5 minutes, but you know how it is. I wanted to briefly note, however, that we have all of this monitoring happening, that the Maumee River, where we see that U-shaped pattern, is not the only place we see it. We also see it in the Sandusky River. We see the increase in Rock Creek, which is the subwatershed to the Sandusky. It's right here on campus. And we see a similar pattern in the River Raisin. Is slightly muted there because there's only 50% agriculture in the River Raisin, and the soil types are quite different. The place where we don't see this pattern is in the Cuyahoga River, that we've been monitoring for a long time as well. That has very little ag, and most of that phosphorus is coming from point sources that have been working really hard to reduce those numbers. Why don't you skip this slide? It's going to have a couple of animations, and then you can go on and click these two. Perfect. And so we do monitor a lot of different sites, and I think it's important to think about all of the different locations compared to each other, similar to what Kim was doing. And what I wanted to note here is that, you know, when we look at the variation that we see either in nitrate or dissolved phosphorus, we tend to see some similar patterns. that like around Grand Lake St. Mary's, where it says Coldwater over there, that we have our highest nutrient loads. We tend to see somewhat higher dissolved phosphorus loads to the Great Miami and Scioto, which are those bottom two watersheds that are the darker purple, because we also have point sources going in there that are higher than some of our, what we would find in Lake Erie. But when we go to something like nitrate, we tend to see that same shade of green everywhere. So we're getting similar loading across a lot of our sites. And so that kind of tells us that the nitrate nitrogen, I might have a couple pop-ups. Jen, maybe try one. Perfect, yeah. That the nitrate nitrogen, tends to be a bit more sensitive to those agricultural inputs. Even with River Raisin, where I just told you has lower dissolved phosphorus, it has similar nitrate loads to all of these rest of these sites, implying that nitrate loads are really sensitive to those agricultural inputs, where something like dissolved phosphorus is reflecting a lot of different things, the different sources, as well as attributes of the watershed, which are important to its loading. And that's all I had to say. I just want to go to a flittering of information for you guys to think about. This is all my info if you need to, or if you want to play with the data yourself, it's online at ncwcordata.org.
Thanks, Laura.
Yeah.
Ed, I will turn it over to you.
Yeah, hello. I know I gave a presentation earlier, so I don't have much to talk about other than, I did want to highlight, I think Laura really shows the nutrients. We're trying to monitor these nutrients on the way to the lake. I think I personally spent a lot of time monitoring the nutrients in the lake, and I've seen with restoration and all this talk, we're continually moving back up into the watershed, and so I think this project is a particular significance. I've seen the federal agencies in the state have some base monitoring program, and Laura, yours is sort of included in some of this. And one of the issues to address, and we can talk about on the panel, is how does that scale to the size that's needed to really match up with the reductions, the investments, the practices that we need. And so I think there's sort of a resolution question. It seems like a lot of dots on your map, Laura, but when you zoom into the area represented by each one of those, it's huge watersheds are represented by a single station. So trying to understand, even if you invest $500 million in one, one of those larger watersheds, it's still kind of hard to differentiate. Are we making a difference? So I'm kind of interested in this space time question and how many more dots do we need, or do we focus our dots? And I think that's one of the good follow-ups that we had, is sort of this targeted approach. I was just at a in-person talk by there was a forum with the head of the US EPA talking in Cleveland, and it was an hour-long talk about the health of the Great Lakes and all the problems with funding. And the last question that he was asked was, what are you most concerned about the health of the Great Lakes? And his answer was, are we spending these multi-billion dollars wisely? Do we know how to spend the money that we have right now? Because Congress isn't going to give us more if we aren't showing progress. So I think this monitoring and also knowing how we can use that information right now to help mitigate the impacts of high nutrients, of high harmful algal blooms. So I think that's all just add to the sort of connecting the dots and this, some of the significance of what we're talking about here.
Yeah, thanks, Ed. So my first question for you three is, we have all this sensor technology and things like that out there. Who is currently using all this data, and who else wants the data, and what can we, how can make a decision on what to do with all of that data? So anybody feel free to jump in.
Laura's probably the best person to start. I know you're familiar with I'd say the data pipeline that goes to Annex 4 or something, but
Yeah, well, so there's different types of sensor data that sort of is coming out of, I would say, a mix of all of our sites. Normally when you think of sensor data, you think of those multi-parameter sondes that are giving us things like turbidity, conductivity, and dissolved oxygen, those types of things. And sometimes that data is a bit harder to interpret. I mean, turbidity is pretty obvious because it's like, if it's high, then the water's muddy. Isn't that great? And that stuff, that type of information is really useful. I know that USGS has been using that information a lot in terms of helping refine loading estimates, and we're hoping to do the same sort of thing. I've looked at that type of information to better understand, like, you know, how do we connect what we're seeing up in the watershed to what's actually happening out in the lake? Are the turbidity numbers similar? You know, is the lake just a big river right now? That sort of thing. But and then we've used that data. We have been especially interested in dissolved oxygen as well. You know, I did a great job of showing those diurnal curves of DO, and you can use that and use a pretty simple model to estimate things like gross primary production, which is closely linked to algal bloom formation, that sort of thing. And so we've been trying to work with some modeling to do that sort of efforts as well. The other side of sensor stuff is when we get to the nutrient side, and sometimes that gets a little bit more difficult to interpret if people are using different technologies. We have to remember that in the lab, we're following very strict and stringent quality control procedures to make sure that what we're measuring is really real and is usable by people like Ohio EPA. And so it's always important to maintain at least some amount of sampling alongside the sensor sampling. It also showed, you know, fouling and issues that can sometimes happen. The other thing is that oftentimes the filtration limits that we need for the lab to say what is actually dissolved, those are different when you're out in the field versus not. So you need to make sure that we're quantifying what we're seeing and clarifying that information. That being said, my goal, and I think that a lot of folks' goals as well, is to really focus some of that nutrient sensor technology in our smaller watersheds where we need high frequency information to be able to detect, really get their best estimate of loads, but also detect changes over time. You know, more data help with that. It still takes an awful lot of brain power on the back end of it to make sense of some of this information. So I don't think it's ready for like the general public or a layperson to look at the data itself. I think it requires a bit of polishing before it would be ready for that. So I'm guessing that you guys probably want to add something to all of that.
It looks like you're on mute there. You're on mute.
All right. Yeah, so the USGS collects a lot of different data. You know, we're interested in DO as well. We're worried when it goes below 5 milligrams per liter. As far as the nitrate stuff and so forth, usually when we have a real-time sensor that's collecting, 15-minute or hourly data, we have to do some work on that data before we formally publish it. But there's lots of different data out there as far as, making those right decisions, right? And I think that's really important, looking at what the needs are of the general public and water managers and going, okay, what are your concerns? Finding partners, whether it's, your university or, federal or state agency, and saying, okay, what's the most important thing? Where do we need to go? And what data do we need to collect, right? And then once you get the data, sometimes there's some surprises with it, right? And also having that data over, multiple years so you can see what the trends are. Sometimes you might not see something in the first year, but you'll see it in like the second year or something's changed. And so, right, trying to scale that into, large sites where there's, large drainage areas and then small sites, right? So yeah, I really think we're in a great opportunity where we're seeing a lot of cool technology come about. And that in itself is its own issue, because we need to make sure that that technology, right, is, taking like a lab instrument and moving it into the field is also important. But I think we're in a great time to see the technology advancements. And I'm looking forward to see what happens in the next couple of years.
I'll just add, I think what I've seen change over the years in terms of who's interested in this data, it used to be the nutrient data fell into a research category that was reported on at science conferences once a year. And we get an occasional 5 or 10-year publication out to summarize a long time frame. And that was kind of the mode, post the Clean Water Act, I guess, that we sort of, wanted to understand the changes. And we've continually shifted that, multi-year look to, Laura, your group having to publish a spreadsheet 1 week and like, can we get that data online? What's the river doing right now? What is the forecast look? And part of it is driven by the need to understand, the impact of those nutrients moving to the lake and causing a toxic, harmful algal bloom. And, having that data connects us to the water treatment plants on the lake that have to deal with the size of the bloom. So I think once we start shifting away from this historical look at conditions towards the quality of water is affecting people's lives right now. The reason we're here today is because we're talking about drinking water. So once we shift our data focus into this operational world, the timelines become extremely important. And I'm always cautious of, watching when we assume that researchers or even university research projects and technicians can respond to that timeline shift with relatively the same data. So I'm excited here because we're talking about really an operational use of this, and how do we mirror what maybe an academic community has done and bringing it into a operational environment where the if that data goes down, it has a lot of implications right now. We're also shifting to a private sector or a third party participation in this data generation. I think we've generally been relying on federal government and grants to sort of decree programs and stations, and seeing this shift to the private sector having a very high demand for this data, really searching the market, searching the technology, patching together funding sources, training new staff on what this data means. So that's also been a paramount shift in the way we approach environmental data that goes outside the plant. I think these operators and facilities have always intensified their look at data in the plants and redone all SCADA systems. But as soon as we get outside the perimeter of these treatment facilities, I think we've always lacked the tools to kind of bring that operational data into the plant. So I think this is a really good project to highlight. We're outside the facility. It's the river that we're monitoring, but we are bringing water into the plant in a special sampling basin, so it's pretty close to plant data, but it's still, what I call source water or lake or river data. So this is a new category of data, and I hope to see it expand, and I hope to see other, I'd say third party or private sector folks contribute to those dots on Laura's maps. I think this is, one of the unique ones that'll be on that map in terms of generating nutrient data outside of a federal program.
Thanks, Ed. And Laura, I know you kind of touched on this earlier about, having to run certain controls and things back at the lab, with all this sensor technology, and treatment plants and facilities looking to use this. Has there been any discussion with Ohio EPA on if it's credible data and if they will take it, as strict as they are on, the certain tests and what you run?
Well, we haven't broached the sensor world issues with Ohio EPA yet in terms of credible data. But I think it's possible. I mean, I know that with the sondes, as long as you're following certain calibration procedures, and during certain checks, I think that, well, at least I know that how stringent USGS is with getting their information online. And so I would think if we followed a similar protocol, then it would be certainly usable data. It gets really challenging when you have, I don't know how to put it exactly, but I think it gets really challenging with sensor data to be like, especially if it's in real time, like, well, do you really trust what it says or not? And then you have to really have a critical eye on that information. You know, I will say that the way that we currently collect our water samples at all of our monitoring stations doesn't fit exactly the credible data requirements in terms of handling, because we have them in an automated sampler for up to a week prior to filtering and analysis. That is an issue. And so, you know, Ohio EPA has already had to been a little bit careful about the circumstances in which they're using the data for loading. It's totally appropriate. If you're looking at it for ambient nutrient quality, then it's a different story, which is why you probably don't see a whole lot of ammonium information from us, because we really restrict that type of data, because ammonium is, as Ed had mentioned before, is so tricky to analyze for, and it's really just not, it's so bioavailable and not very stable that, you know, we don't feel comfortable as a lab, you know, be like making that openly public. But all of that being said, I will also note that there is a certain amount of stuff that from that, you know, when you take your sensor, or we have our water quality in our lab, you know, we analyze for all kinds of things, but there aren't sensors that are really developed for analyzing for that give us really important information as well. So, you know, I don't see a future where we won't be doing a combination of both things. I think though that the frequency at which we do the grab sampling may shift as we move forward.
Kim, do you have anything to add?
Yeah, you know, when we started our project, that was the thing that was really important to our partners, is they were like, some things you might be able to use, and we might be able to, you know, do surrogates with, right? Or we might be able to use real-time parameters eventually once the technology is there. But we agree with Laura there that, yeah, there are some parameters that we will, you know, I don't know when, maybe in my lifetime, the technology will be there, if ever. And some things relate really well with stream flow and other ones do not. The other things seem to rule them, like the ammonia and the orthophosphate, and it varies by stream, right? So definitely that, you know, I think with the technology, and this goes into, you know, there's different types of real-time sensors, the stuff that's been around for 20, 30 years that we're really, you know, it doesn't, you know, we can put it out there and we check it like once a month or once every 2 months, or, you know, every couple of weeks, depending on conditions and fouling that's going on. But there's these, you know, new sensors where, you know, it's in our best interest to have someone like at the site almost every day. And you guys maybe can speak to with the ammonia sensor, how often people are going in and you know, updating it or fixing it and so forth, which I'd be really interested in knowing. But yeah, some of these newer technologies, right, you know, you might need to service, you know, daily or weekly still, and or bi-weekly, you know, everything's going to vary. But yeah, and that's one of the things I think is really cool about this project, is to see, you know, okay, these were the pros, these were the cons, this is the lessons we learned. And going forth, if we were going to put this out in other places, this is the recommendations we would make. And, you know, this is the time commitment that you need to have and the personnel available to manage this piece of equipment, which is, I think, is really important, because, you know, everyone gets excited, you know, oh, we're going to have real-time data, but, you know, there's a lot of work on the back end and behind the scenes that people don't realize that goes on.
Ed, do you have anything to add?
Yeah, I think we're, you know, starting to differentiate or add additional decision support tools here onto this nutrient issue. So the, you know, some of Kim, what you brought up, I think is really addressed by this project. Is the wastewater or the water treatment plant wants to know right now what the ammonia concentrations are, and they're fine with a shoot from the hip. Tell me right now what this instrument can give me, and we're going to change what we do inside the plant. Now, actually storing, saving, archiving that data and saying it's the same as, or, you know, could be used alongside Heidelberg's, you know, ISCOs that are transported to the lab with QA/QC. They're clearly different data streams, even though they're centered around the same parameter. So I think we're just going to start seeing to have to differentiate data for what purpose and deal with any complications of using this real-time data to try and infer relationships with other programs. So, we've certainly dealt with this a lot on the lake side for a long time. Everyone goes out and randomly collects water, the same quote, water sample for many different reasons. So I think it's just helping to reemphasize the reason for communication, metadata tagging, and I'm fine sharing quote real-time nutrient data, but it's really for what purpose? Like, what are people trying to get out of it? For the water treatment plant industry, one of the main reasons just to share it was just for sheer transparency. We're not trying to hide anything. If you want to try and interpret that real-time sensor, knowing that the quality isn't, we don't trust it 100%, but we're happy to share it for transparency. And it at least engages the conversation. We've had TV reporters then that go and show, hey, the water in Toledo must be bad because the sensor shows the green spike is up. And, so then it just leads to a discussion about, well, how we treat water and what we're watching and what's involved. So I think it helps raise awareness, transparency, and just brings a discussion. We're gonna have to figure out with this data stream that I showed, how to caveat or put, preliminary, not quality controlled, or, there's gonna be certain issues that we just can't address in real time, given the time, budget, and resources for it. And I think the main objective is what information does the plant need to make its decision, and how do we keep on task with that? And Kim, you had one question about the how often we visit these, and ideally it would be every 4 to 5 weeks we'd be able to change out reagents and really get a mini overhaul of the instrument to be ready for another 4 weeks. You could certainly do checks every day, and the plant does all kinds of checks every few hours anyway. So there's just how do we figure out the routineness of what can be done with the instrument and what's the data looking like? So
Thanks. And to wrap things up for this panel, I'm going to go to Tom's question in the chat. He made a comment about it's obviously very expensive at this scale, and where do we see all this research going the next 5, 10, 15 years? I guess we'll start with you again, Laura.
All right. Yeah. So yeah, it's right. So monitoring at the scale is expensive, but to give some perspective, the SON, the multi-parameter SON that measures the dissolved oxygen, that stuff that we have at our sites, if we get it completely built out and then like connected into real-time data, is probably like about $20,000 just for a site. And then when we replaced all of our colorimeters, like our auto analyzers, to measure things like dissolved phosphorus, like one of them that measures 3 different things on data that we've been using for almost 10 years now, that on its own was like $30,000. And so thinking about the relative expensiveness of the sensor technology that's available now versus if we just took stuff back to the lab, think of the geographic scope that we would have, right? So those 2 things are really important, of course. So I think moving forward into the future, we're going to see sensor technology get less expensive, and being able to have it connected in real time be less expensive. And then that's where we're going to really see the doors open, because at some point we're going to have to see a trade-off. Like right now we have chemists in the lab that are working really hard, and they go out in the field once a week and they're like, yeah, I guess we're kind of in the field, but really we're chemists. And at some point we might start to see that flip around and be like, no, what we need are people that are out dealing with the sensors more in the field and managing field locations and making sure they're operating correctly, and then maybe have fewer people in the lab. So, assuming that we see some sort of a changeover in that manner, I think that's where things would ultimately go. And we're still, I think, hindered right now, until we have a good orthophosphate sensor that's not just like colorimetry in the field, but an actual sensor. I think that there's going to be some limitation as to how much we can deploy things. Although that being said, our experience with the new lab The Green Eye Scientific New Lab technology has been great, and it matches up fairly well with our data. So, you know, it's just a little bit more reagent heavy, a little bit more manpower than just throwing a sonde out for 3 months straight. So, and also a little bit more expensive. So that's where I think the managing those costs is going to be the real challenge in the next 5 to 10 years.
So I'll jump in next. So, you know, that's one of the things that the USGS is really interested in. We have a program called the Next Generation Water Observing System, or NGWAS, which is looking at real-time data for water quantity and quality, necessary to support, you know, water prediction and decision support systems for daily operations, but scalable, right, at an affordable level. And so Congress has approved $4.5 million for the USGS in the next 2 years to work with universities to really advance those sensor technologies and so that they're scalable to the regional national monitoring networks that are out there. So I'm really excited about that. You know, we all want to have, you know, as much data as possible, but we have to have it in a way that, you know, helps us make those decisions. So not only is it having that, you know, system out there or the sensors out there, but we have to have a system to, you know, recognize the data, look at the data very quickly and make decisions, right? And so having, you know, maybe new technologies in the future, they are scalable, and that also, you know, looking at ways we can support displaying that data for managers to make decisions, I think is really important in the future. So that's all I have to say.
Yeah, I think my perspective on this comes from what I've seen in the industry, and I've, you know, just sort of relying on the science researcher instrument set and assuming that that scales to the type of measurements we're talking about here. And it, you know, I can say it doesn't, and it's very expensive if we just sort of buy what's on the market today. I think Kim, it was good to hear sort of that, you know, I think the procurement part of this and how we foresee the decisions that need to be made, put it either a challenge out to the industry or just go and spec the instrument directly and just say, you know, the USGS or the state of Ohio or the Maumee River Watershed Collective wants to buy 100 nutrient analyzers. We want them to cost, you know, this much. We want them to have this capability, and the industry will respond. I mean, what I've been able to do with this new lab over the last 3 years is, you know, grab a small cottage industry supplier on the East Coast, bring that technology here, do multiple demonstrations, work it into research projects, really hone in on the reagent part of it, lowering costs with reagents, cracking open the nutrient chemistry, getting more familiar with it, working on a redesign to get a smaller, easier to deploy product. So I think it's been a, you know, I've helped with that technology transition using some of my engineering skills and some of our research projects, but I, you know, quite haven't seen it move to a procurement method from the people that are being affected by this or could move dollars in this mode. So we're always sort of playing catch up with what people money have, and when they, you know, we need to spend this right now and here's what we need to do. So I think if we step back as a group to either the watershed scale or the state scale and just issue that challenge of how many dollars we see coming for investments, really what's at stake, I think we can push technology really fast because all of this technology is available. It's just getting that specific application and then the training set up for people. I mean, I would hate to see us, you know, the only way we can scale IFCOs is hire more people to drive vans around to pick up samples. So, you know, I don't think that's the best use of our resources if we're trying to just get a different mode of collecting data. So I think it's really within our hands. It's not so much the future as much as in what do we put out to the industry and how do we collaborate with funding agencies as well.
Just to sort of to support what they're both saying. You know, when I look at my budgets and think about the cost of running a monitoring program, it's people cost more than everything else, right? Just having, you know, enough people to be able to make your program work. Like, yeah, there's a high upfront and, you know, equipment costs. And on either end, whether you end up with more sensors and less in lab work or vice versa, it's always going to be having the right people on your team to make sure you're getting the best information. And that will always be the highest cost. I just think that the people might shift a little.
Absolutely. Well, thank you to all of you for speaking and sharing your thoughts. At this time, I will turn it over to Jen.
Yeah, thank you, everyone. I think this was really great discussion and really good questions, Kevin. You know, it actually really gets at the heart of kind of the next agenda item, really, other than Jeff doing some wrap up and some kind of summary comments. I really just wanted to get at the question of kind of what's next, right? We've been working on this concept and had this vision for sort of smart water, and how do we bring the smart Lake Erie concepts back to the watershed. So yeah, the Maumee River behind us and the upper Maumee specifically, you know, are the focus for us. You know, like Ed mentioned, it's drinking water. It's a real problem, right? We're not just studying sort of a hypothetical situation or, you know, a random research question. We're really trying to take good data and make the decisions that are best for the city based on the information that we're collecting. So yeah, I mean, talking about how we bring the cost down and how we do some of these other, how we follow the technology. And I think, you know, we've all continued to hear how much funding is available for this type of work and how much possible funding is coming to support these types of efforts, right? So I'm just going to share my screen here briefly. Just point out a couple of projects that the city is working on. Can you all see my slides or my daughter?
We can see it, Jen.
Okay, great, thank you. So Defiance has been working on a couple of different projects that I just wanted to mention. So I'll let Sabrina Brown, Dr. Brown with Defiance College, will just talk briefly about the Defiance Alliance, some funding that was recently awarded through Senator Brown's office that will continue to focus on work in the Upper Maumee. Conservation KIC is a program that we have partnered with the Great Lakes Commission. The city has contributed about $10,000, and there's $10,000 of GLRI funding, working with Tyler Miller, who's on the call, and actually had some great questions. Maybe we'll have time to get to a couple of those here at the end. But Tyler designed a denitrifying bioreactor that will be installed in the Platter Creek watershed. So that, again, is in our source water area. That's a project that we have worked with Nicole Zaccarda at the Great Lakes Commission and hope to be able to do some monitoring. Mike Zedike is our landowner, and he is in favor of monitoring that practice, or edge of field practice, which is, you know, that's different than what we're doing now by monitoring the tributaries. But we have a big H2 Ohio wetland project. Tom Denbo is on the call, and he's our project manager with Biohabitats, managing that. The city acquired about 40 acres of floodplain property adjacent to, only separated from the Maumee River by old 24 East River Road. So we will be continuing that project over the next year and a half. Hopefully, if things go as planned, we'll be constructing that wetland project this fall. Still in the early stages of that, but almost 1.5 million from the ODNR H2 Ohio project was set aside for that. And then lastly, the city is kind of a silent partner on the U.S. Army Corps of Engineers, Ed from Limnotech and others from USGS, a lot of partners involved in this. It's basically a 5-year research project. It's P-optimal wetlands. You know, I guess not all wetlands are created equal. So really studying
a lot of monitoring is going into this project and really studying the optimal soil conditions for capturing phosphorus out of the wetlands. So be glad to take questions about those, but I don't need to really go on. You can always contact me offline or sort of follow our Land to Lake news that we put out to get more information about those projects. But Sabrina, I don't know if you're
I'm here.
on. There you go. So yeah, I just wanted to give Sabrina a chance to talk about this project with Defiance College.
Yeah, so hi, I'm Sabrina. I haven't met a lot of you yet. So I'm in my second year here as an assistant professor of environmental science at Defiance College. I'm sort of come from the paleoecology side, so I'm a diatomist who a lot of my research up until now has been in lakes, trying to understand disturbance through time, and sort of as a part of moving into the Maumee River watershed, have gotten involved in more monitoring projects, right, as we've gotten students involved in research over the last year or so. This Tri-River Alliance sort of aims to address these primary concerns we have with nutrients and HABs throughout the Upper Maumee watershed, and it really focuses on a collaborative research and education program involving Defiance College and the City of Defiance, and getting high school students involved, FFA students as well. So really the focus is sort of enhancing training for secondary and post-secondary students within Defiance County, but also sort of integrating research questions with useful data collection for the city, right, to help with making real-time decisions about water quality. And so really the goals of this include, right, creating this collaboration and also creating a data center at Defiance College, sort of hopefully focused on filling in some gaps that we might have, within the Upper Maumee watershed. And so since I'm a diatomist, we've really started in our discussions with the city to think about focusing on some algae counts and sort of that kind of analysis, and really just getting students into the field, right, doing hands-on things in the field and in the lab. And sort of the other piece that sort of feels like is missing and that students could help with is just making any of the information we have available to the public in a format that is easily digestible, right? So making infographics and just making that data presented in a way that kind of makes sense, like why should the general public care about, right, water quality and that kind of thing. So there's a QR code to the press release, and I'm also gonna pop that in the chat window. I would be happy to take questions or move on.
Yeah, Sabrina, I don't see any questions in the chat right now on that. Thank you for putting the link in there. Oh, Carrie asked a question. What is the funding source?
So the funding sources, it's a government earmark supported by Senator Brown's office.
I think it's coming through the Department of Education.
Yeah, that sounds right.
So it was supported in the recent omnibus bill, if I understand correctly. And Senator, we made the request came from Defiance College in partnership with the city. So the request went to Senator Brown's office, and then he supported it and put it forward in his list of requests. They had, I think it was maybe around 100 projects throughout the state of Ohio that were supported by Senator Brown's office. So this was one of those projects. We, I think, responded back to our team and to the college president, Dr. Mankey, and let her know that it was an easy, let me know if I get this correct, Sabrina, but he said this was an easy an easy request to fund because he felt like it was a really collaborative effort and it was a, to a very relevant situation. So we're looking forward to working together and developing that program as the next year unfolds. So I just have one more slide and then I'm going to introduce Jeff. This is actually kind of an old slide. Oh, Laura Johnson has another question. Sabrina, I'll let you answer this. Will Defiance College be building a water chemistry analysis lab?
Hey, Laura. So that's not really the plan right now, just because that's not my specialization. And sort of as we've had discussions with the city about the things that they need help with, sort of they do a lot of analyses in-house, with the exception of orthophosphate and phosphate, right? And so, I mean, that's not really the plan right now. We're sort of toying with the idea of maybe getting some sensors and that kind of thing. But I just got an email from Chris Winslow, and he would like to have a meeting, Laura, and he put you as a suggested person to sort of talk about sort of what equipment we're actually going to be establishing. So stay tuned for that invitation.
Yeah, I'd be happy to have a chat about all of that, sort of brainstorming. I'm sure probably some of the stuff that Ed has said today would be useful as well, but brainstorming sort of what you want to measure and how and where and that sort of thing. So it's exciting.
Great, thanks. Yeah, thanks.
Yeah, one of the early steps that we're taking right now is to develop a list of folks that are interested and willing and able to participate on the, there'll be an advisory committee that'll be co-chaired by the mayor and the college president. So we're coming up with a list of folks that would be good resources for that group and to kind of help advise as we go forward. So if you're interested, please reach out to me or to Sabrina and let us know. I mean, obviously, there's some folks that we'll be reaching out to as well. So Tyler's asking a question, will testing be done on field level or what watershed level? So I think that remains to be seen. I think we're, that's one of the questions that I was trying to pose in this sort of last agenda item. So I'm really interested in getting feedback from the city's standpoint, right? Where is phase 2 going? We consider this project, this lost project, as phase 1 and think about where does phase 2, where does that take us? So that's, I'm just going to put up this slide of partners. I apologize, it is a little bit outdated, so I don't have gloss on there, and I don't have some of the folks that we've currently worked with. We've got folks at UT and BGSU. I know, Tom, you had asked a question about reaching out to George Bullerzon at BGSU. We have had early conversations with him, but not recently. So anyway, I just wanted to recognize that we've had this vision for a while, and we had conversations with a lot of partners, and I think Jeff will talk a little bit more about this, but we are kind of entering into that phase where we've shared the vision. We've developed good relationships with a lot of our partners, and now we need to kind of really define and implement and execute. What we've been doing, I think, are baby steps, right? Small demonstration projects and small projects that we feel are scalable. So if there's any comment or any discussion on that, please feel free to jump in on the chat function, or I think there's a raise your hand function. That's fine as well if anybody has comments. Otherwise, hearing none. I could put some folks on the spot, but like I said, I think we had some really good discussion at the end of our second panel there about where do we go from here. So I will move on to Jeff. Just has one slide here. So Jeff, without hearing any questions or comments in the chat, I'll just turn it over to you.
Jen, I had one comment here. I dropped it in the chat, but if folks are interested in attending this Defiance treatment wetland tour, there's an open house on May 13th. So I dropped the info in the chat. Feel free to follow up. So it's an opportunity to see the nutrient sensors in person, as well as sort of continue sampling, and it's right next to the reservoir as well, so you can get to see the reservoir too.
Yeah, thank you, Ed. Jeff? why don't you
Yeah.
Take it away.
Yeah, I'm ready. Thank you, Jen. I appreciate it. Let me first thank the staff of the City of Defiance. I think that when you look at our utility functions here in the city with our staffing of Adam and Joe and our wastewater facility with Mark and Kevin, and you intertwine that with Jennifer English, I think you get to understand that the alignment in the City of Defiance with not just the utilities and water quality issues. I think it's something that I think gives us a real advantage, and I'm proud to say that these people work very hard at what they do, and they've been instrumental in moving these kind of issues to the forefront, and will continue to do that. I've looked at the list of attendees, and I can tell you that it's quite impressive. I think that from science and research, there are a number of people that I've met over time that have been really what I would call heavy hitters in the science of water quality issues within this watershed. And I thank them, but they're all assets. Everybody on this list is a tremendous asset. I think in Defiance, we've talked a number of times about the importance of technology, and it's nice to see people from Metalink and Watch Communications on. That will be playing a very instrumental part in moving this agenda forward and moving this city forward, and really providing the necessary results for water quality issues in the region. The city has taken on many endeavors, but one of the one main thing that we've tried to do over time is this city wants to start taking a look at what we call smart and sustainable concepts. We want to use technology in such a way that it moves this city forward. And if you're wondering why the city is so much interested in water quality and going out into the tributaries and measuring, it's because we want to be the leaders. We want to set an example. We want to get outside, think outside the box in terms of water quality. And, yes, we put a $10 million GAC system in our water plant, but it's more than that. I think Adam really expressed well that, we have to do something different. We have to try to solve these issues. Our philosophy in Defiance has been that we can solve these issues and we can accelerate the change and innovation of water quality by creating a collaboration. And I think that it's incredibly important to develop partnerships. And the people that I see on this list, and I'm happy to see people from the city of Toledo. We have Fort Wayne, Indiana represented. Napoleon's being represented here. So that collaboration and working within the confines of municipal governments, I think, is critical. And when I look at that, we have the tendency to call that more vertical thinking. We have these things that align very well for us. We have utilities, we have different divisions of police and fire, and we're all connected in that way. But the true solution to this issue will be providing that collaboration and doing more what I would call horizontal thinking, where we're moving across organizations. We're moving more toward the educational systems and science and understanding what the science is doing and partnering with science, partnering with business community and partnering with the ag community to help solving these issues. This city has never wanted to point the finger as to the reasons why we see the rivers and the tributaries in the in the shape that they're in, or these algal blooms, this city's more interested in finding the solutions and working and partnering with people to move it forward. And I think that if you look at the slide that you see before you, we have spent a number of years to try to develop those relationships. And I think that the real purpose and the real the real opportunity for advancement is bringing government, is bringing education, and is bringing the business community together to help solve these issues. I've heard numerous things where Laura Johnson talked about not having enough people. Well, we've set aside money within our consent order and within our mandate to actually go out into the tributaries. And you should know that the City of Defiance can be a resource for you as well. And I think that the message that I want to send today is that if we really want to move the needle, let's create those partnerships. If you really want to know where we should go from here, it is really building that partnership and that collaboration to work in unison with one another and understand the connections that we really do have with water quality, and creating the kind of alignment that will accelerate the change that we want to see. I think so many times we've seen over the years that there's been a lot of frustration. All you have to do, honestly, is to read the Toledo Blade, and it's very evident that there's been a lot of frustration in Toledo, Ohio, and rightfully so. We want to partner with the Toledo community. We want to partner with the Fort Wayne, Indiana community. We want to partner with the universities and business, and we want to move the needle on water quality within this region. And actually, it's the prime time to do it. If we've had this much interest from these organizations that I look at this list, it's evident to me that there's an interest, and all we have to do now is sit down and partner with one another and take a piece of the action, so to speak, and move it forward so we can have a movement where we can accelerate the need for change and create better outcomes for water quality. So I thank everyone for attending today. I really thank the staff for putting this together. I know that everybody's time is valuable, but we will forge ahead, and we will move forward on the issues of water quality. And I want to thank everybody for attending today's session. So thank you very much. Jenna, I'll hand it back to you.
Yeah, thank you, Jeff. We've been sharing this concept and this vision for a few years. We've been in Cleveland at the Great Lakes Economic Forum. We've been at Washington, D.C. at the National Institute for Standards and Technology. We're participating with the Intelligent Community Forum, trying to get we're not one of those big urban centers as a smart city, but trying to take some smart city concepts and apply that to things that we do, not just in water quality, but throughout our city services. So thank you, Jeff, for speaking about that. And we will be putting together just a very short Google Docs, probably Google Docs, but a very short survey that we'll be sending out to all the participants, asking you input on future topics. So we envisioned this as an initial workshop to talk specifically about the GLOS project, but we realized that we couldn't really dive deep into any of these topics today. So we recognized this was just really kind of an overview, and we intend on having a series of workshops. So we'll probably do one in the late summer, one in the fall, early winter. So we'd love to get your input and feedback on how we did today, what we could do differently or do better, and what you'd like to hear more of. So thank you all for your time and your participation. We do have a recording, as long as everything went smoothly. On this end, we're not used to doing this a lot, so hopefully the recording will come through. I'll be able to share that with folks who were on the call and some folks who registered but weren't able to be here today. So if there aren't any other comments or questions, then we will go ahead and sign off. And again, thank you for joining us. Oh, there is one question or one chat here. Just to thank you. So, okay, with that, we'll sign off and thank you again to GLOS for funding our project and for all the participation from our presenters and panelists today. I'll stick around here for a few minutes if anybody has any last comments. Hey, Paul, thanks for sticking around. Anyone from our GLOS team that wants to stick around and kind of do a little debrief, feel free, but I know some folks might just be still on mute or still, somebody may have had to step away, but
I'm hanging around, Jen, until you kill it.
yeah, sure. Thanks, Bruce. Nice job, everybody.
Yeah, same with me, Jen. You might want to take the last screen out. We can see the gallery view of who's left.
Oh, yeah, sure. I appreciate everybody's suggestions along the way that said, hey, turn this off, turn that on. This is not my strong suit here and running all these different screens. I've joked about, I don't know if Jake's still on there. Yeah, Jake Lambert, you're still on there. I've joked about like not wanting to go to the dual monitor thing. And today, I don't know if I was texting with Joe or Kevin today, I felt like I needed like 3 more monitors so that I could see everything, see the different PowerPoints and the different screens and stuff. So I really hope, I'm going to go ahead and stop the recording, but I really hope that that comes through so that we're able to share it.